Hello friends, today we will see three hinged circular arch. We already completed a parabolic arch. Now we learn the circular arch. Okay. Let's see first a circle. Suppose this is a circle and this is the diameter. And if I cut this circle through this chord and consider here as a 1 hinge and here as a 1 hinge. Now this segment is called as a circular arch. Okay. Now, and if I consider at the top point as a hinge point, then this is called as a 3 hinge arches. I just draw a separate diagram of this segment. This is the first hinge point A, this is the second hinge point B, and this is the crown point C. Here is a third hinge point. Let's consider this is the length segment, length L. We consider this as a L, and this is the height, or it is also called as a rise of the circular arch. Okay, now this is the circular arch. Before starting the analysis of this 3 hinge circular arch, we have to know some formulas to find of the 3 hinge circular arch. First formula we required, that is the radius of this circular arch. So we have to find out the radius of the circular arch. This radius of the circular arch is nothing but, suppose this is the circle. Here from the center point, this is nothing but the radius of the circular arch. To find this radius, we have one formula, that is R is equal to L square divided by 8H plus L divided by 2. Here L is the span of the 3 hinge circular arch and H is the height. Okay, this is the first formula you have to remember. Now second thing, we have to require a Y. Y is nothing but the, suppose if I consider any point on this circular arch, and we have to find out this height of this point from the baseline. Now this is nothing but the Y. So this Y is given by the formula R square minus X square minus R plus H. Here in this formula, this R is nothing but the radius and this X is nothing but this distance. Remember this. Okay, in case of 3 hinge circular arch, this X distance is always select from the crown point. So this is the distance X. So this is the important things. In case of 3 hinge parabolic arch, we always consider the X from this hinge point. But in case of circular arches, we consider X from the crown point. Okay, remember these things. Now next, if I want to find the normal thrust at any point, we require the value theta, that is the angle. Suppose this is a D point on the circular arch, and at this point I have to find out the normal thrust. As you know, in the normal thrust formula there is a cos and sin theta, so we require this value theta. So this theta is nothing but this value. If I draw a tangent, so this is nothing but your theta value, and this theta is equal to sine inverse of X by R. Sine inverse of X by R. So you have to remember this formula before starting the analysis of 3 hinge arches. Then one more things we required, that is one mathematical things we required many times while solving the problems of circular arches, that is the derivative of root of f of x function. Okay, so remember the derivative of this root of f of x. The derivative of this is d by dx of fx divided by 2 into root fx. Okay, so this is the derivative of root of f of x. Remember this. These terms may come while solving the problems. So you have to remember this derivative. Okay. Now we will see a small problem based on 3-inch circular arch. So this is the problem. A circular arch rib of 20 meter span with central rise of 4 meter is hinged at the crown. It carries a point load of 125 kN at 7.5 meter from the left hand hinge. Calculate the horizontal thrust of the arch, the reaction at the supports, and the maximum positive bending moment. Okay, so this is the circular arch is given. Total length, total span is 20 meter, rise is 4 meter is given, and 125 kilonewton load is acting at 7.5 meter from the left hand hinge. That is, this distance is 7.5 meter is given. Okay, so we have to find out the horizontal thrust, the reaction at the support, and the maximum bending moment. Okay, now we solve this problem. First, we will try to find out the support reactions. Okay, by support reactions is calculated by applying the equilibrium conditions. So applying conditions of equilibrium. So first I apply conditions of equilibrium. Summation of moment at A is equal to 0. Okay, first I apply this condition. Moment at A is equal to 0. Okay, so take the moment about this point. 125 into this distance 7.5 minus VB into this VB into 20 meter, okay, is equal to 0. So VB is equal to 46.87 kilonewton. Now we use second equilibrium equation, that is summation of f of y is equal to 0. Summation of all vertical forces is equal to 0. So VA plus VB, these two vertical forces, minus 125 is equal to 0. Put VB value as we calculated and find the value of VA. So VA is equal to 78.13 kilonewton. This is the value of V. Now next apply third equilibrium equation, that is summation of f of x is equal to 0. Okay, if I take summation of x is equal to 0, so in this case HA is in this direction and HB is in this direction. So HA minus HB is equal to 0. So this becomes HA is equal to HB, and consider this is equal to H. Okay. Now next, to find this value of H, that is this horizontal thrust, this H is nothing but the horizontal thrust. This HA is equal to HB, and I consider this HA and HB is equal to H. So to find this H, we take moment about this crown point C is equal to 0, because this C point is a hinge point. If I take moment about this point, it should be equal to 0. So to find the normal thrust, to find the horizontal thrust, we take summation of moment at crown point, that is C point, is equal to 0. Okay, so in this diagram we have to consider either left or right side of the portion. Okay, so if I select the right side of the portion and take the moment. Okay, so moment of this right hand side is VB into this distance and HB into this distance. Okay, so I just write the moment. It is VB into this distance is 10. So VB is we already calculated 46.87 into 10 minus HB into 4 is equal to 0. This 4 is nothing but this height. Okay, so from this HB is equal to 117.17 kilonewton. Okay, so this is the value of horizontal thrust, and HA is equal to HB. We already proved here is equal to H is equal to 117.17 kilonewton. So this is the value of horizontal thrust. Here we find out the vertical reaction, then we find out the horizontal thrust also. Now we have to find out the maximum positive bending moment. This is, see the problem, we already find out the horizontal thrust, then we find out the reactions at the support. Now we have to find out the maximum positive bending moment. Okay, after seeing this diagram, we can say that the maximum bending moment point occurs at this point D, that is at the below the concentrated load. So if I want to find out the maximum positive bending moment, we have to calculate the bending moment at this point D, and this bending moment at point D is a maximum positive bending moment. Okay, so let's see how we find out the bending moment at point D. Okay, so to find the bending moment at point D, we have required this height. Okay, so first we will try to find out this height. To find this height, there is one formula, y is equal to square root of r square minus x square minus r plus h. Okay, so this is the formula to find out the value of r and y. So in this formula, first we have to find out the radius, that is because we require that radius. So this radius is equal to, formula for radius is L square 8h plus h divided by 2. So L is nothing but the span, that is 20 meter is given, 20 square divided by 8 into h, value of h is a 4 meter plus h, that is 4 divided by 2. So the r is equal to, value of r is equal to 14.5 meter. Okay. So put this r value in this equation and find the value of y. Okay. So therefore y is equal to square root of r square minus x square minus r plus h. Value of h is given, that is 4 meter. R just we have find out, and x is nothing but this distance. X is nothing but this distance. This is the x distance. So here up to this ground point is 10 meter, up to this point is 7.5 meter. So x becomes 2.5 meter. Okay. Now put this value in this equation. So y is equal to square root of 14.5 square minus x is 2.5 square minus 14.5 plus 4. After solving this, the value of y is equal to 3.78 meter. Okay. So this is the value of y. It is 3.78 meter. Now to find the maximum bending moment, take the bending moment at this point D. Okay, so to calculate bending moment at point D, consider either left side of the segment or right side of the segment. I select the left side of the segment and take the moment. So moment produced by this VA force and moment produced by this HA force will comes in picture. So therefore maximum bending moment is equal to bending moment at point D is equal to, so bending moment is VA into 7.5 minus HA into this Y distance is 7.8 meter. Okay, let's see. So we're taking the moment at point D, this VA into 7.5 and this HA into this distance. This distance is a Y, 3.78. So VA we already calculated. It is equal to 78.125 into 7.5 minus HA 117.17 into 3.78. This becomes 143.03 kilo Newton. Okay, so this is the maximum bending moment. Maximum bending moment, kilonewton.